Several years ago, my main work was work on web accessibility in the Netherlands, and I kind of gravitated away from doing accessibility work because I didn't tend to like a lot of the people, and the reason is that there are only 3 nice accessibility experts in the world, and one of them is here today. This is Leonie Watson.
Good to go? Well, good morning, everybody. I don't know if I'm ever going to get the courage to ask who the other 2 are, but that's maybe a conversation for later. It's really great to be here this morning, and I hope you're all not suffering too badly from last night. I'm Leonie Watson. I'm an accessibility engineer with the Paciello Group. We're known as TPG on less formal occasions. I'm also the accessibility lead for the UK government. And through both those jobs, I spend a lot of time working on some W3C stuff like HTML5, SVG, and the ARIA specifications. Today, I'd like to talk to you about some different APIs that are available that can help make a difference in terms of accessibility and user experience for different groups. But before I do that, I want to actually just take a look at what happens in the browser when we put together some really simple old-fashioned, old-school HTML, because the answer might surprise you. There's a hell of a lot that happens without us as developers having to really lift a finger beyond doing some basic coding. So when you write HTML, this is probably the most important thing in terms of accessibility, particularly for assistive technologies like speech recognition tools or screen readers. And that's because it's the HTML that contains all the valuable semantic information about the content that's displayed on screen. So when you write some HTML code, you'll discover that most HTML elements have what we call default implicit roles. That just simply means that when you use something like a paragraph or any other kind of tag, the browser knows what that tag is for and will make that information available to assistive technologies like screen readers. So if we use the image tag, then the browser knows it's an image. Depending on the platform and the browser, it'll tell assistive technologies, treat this content as a graphic or an image. And it's really as simple as that. All you've done is use the basic HTML element. Main is another example, a slightly different one. Its default role is main, but this role has special features for accessibility. It not only tells assistive technologies what the purpose of the element is, but it also creates a navigational landmark. So most screen readers, for example, have a shortcut that lets you move focus from one navigational landmark on the page to the next. So it's a really easy way of getting around content. But what makes them really interesting is that when the screen reader arrives at one of these landmarks, it not only moves its focus on the page, but the screen reader also announces what the purpose of that area of the page is. So in this case, with the main element, you get told it's the main region of the page. All the HTML5 sectioning elements do something similar. So a side will tell you that it's complementary information. Header and footer, when they're scoped to the body, will tell you that it's the banner or the footer of the page. The nav will tell you it's a navigation area. So there's a lot of information available to assistive technologies just in these basic HTML elements. When I said most HTML elements have default implicit roles, span and div are the exceptions. They do have roles, but they're very weak, which is basically to say that they're meaningless to assistive technologies. So when an assistive technology comes across a div or a span, it'll just see the content, usually some text, and treat it as such, plain text. Doesn't matter what you do to script or style or make your divs and spans look interesting when you're creating custom controls. At the end of the day, a screen reader or a speech recognition tool is just going to see some plain old text content in these 2 particular elements. And that's really worth remembering, particularly in these days of JavaScript frameworks where we see a lot of interactive elements created out of spans and divs. You'll also get an accessible name for many different kinds of HTML element, and these can be acquired in different ways. When you use an anchor link, you have the link text inside the anchor. That provides its accessible name. And all an accessible name does is differentiate this particular element on the page from any other element of its type. So link text is what helps us tell one link apart from another on the page. You can also get an accessible name from an attribute. Going back to the image tag, if you use an alt attribute to provide a text description for an image for people who can't see it, that provides its accessible name, how you differentiate it from every other graphic on the page. You can also get an accessible name through an associated or paired set of elements. So the label and input, either when the label element is wrapped around the input or it's paired up using the for and ID attribute pairing, the text string of the label provides the accessible name. So someone using speech recognition could just target this particular input by speaking the name of the label and instructing the speech recognition tool to click on it, interact with it in some way. You also get information about state. A couple of easy examples. These are mostly in native HTML related to form fields. We've got an input here that's just got the checked attribute on. Visually, of course, that puts a little marker in the checkbox, but the browser also exposes information to assistive technologies to say that this particular checkbox is in a checked state. And obviously, that can be toggled on or off in a pretty standard way. You can also have a required attribute. Again, there's a visual manifestation of that. And again, the information's also made available to assistive technologies. So knowing what state something in is a really important piece of the puzzle when you're starting to interact with something in terms of web content. The last thing you get for free when you're using native HTML is focus and keyboard support. If you use, for example, an anchor link with an href attribute, and the attributes are really important, the link becomes focusable, which means that if you're a keyboard user, you can tab onto it, which is pretty much 101 for being able to interact with it using a keyboard. But you can also then activate the link using the Enter key, and the browser just provides all this for you. Similarly, if you use a button, it's focusable, you can get to it with the keyboard, and in this case, you can activate it using a space or Enter key. And this is standard right across all browsers, just for using the basic HTML elements. So something I loved that Vasily said yesterday, get the hammer count. When it comes to accessibility, using native HTML means you get a hell of a lot of the hard work done for you. It's not always possible in the real world, of course it's not, but if you can, use HTML. We're really not joking when we say this, because it's more hammock time if you can. So how do all these assistive technologies get at this information? Well, the answer is through accessibility APIs. And they're available on every platform. There's MSAA, UI Automation, and iAccessible 2 on Windows. iAccessible 2 is also used on Linux, along with the ATK API. There's NS Accessibility Protocol on OS X, and more on iOS and Android. So every platform has an accessibility API that makes all of that information I was just telling you about, the role, the state, the name, available to assistive technologies when they query it. And the nice thing is that if you look at a control on the platform, this is a checkbox buried somewhere in the Windows 10 control panel to toggle a bold state on or off. This is the information you'd get if you were looking at it using the MSAA API. You'd be told that it has a role of checkbox, that its name is bold, and that it's focused, checked, and focusable. Lots of really useful information there. But the really neat thing is that if you were to use this code to recreate the same control in HTML and look at it using the same accessibility API, the information you'd get is absolutely identical. So from an assistive technologies point of view, it doesn't make any difference whether the checkbox is in the operating system interface, in an application interface, or part of web content or a web application. The information is there for the taking, and that really does make life an awful lot easier. When you know what you're dealing with, you know how to identify it, and you know what state it's in, so you know whether you can interact with it or not. All of these relationships, so how controls at the platform level map to controls as we create them in HTML, are being mapped by the W3C. And the document has just gone out, I hope, as a tweet off my account, and my handle is at the bottom of the slides there if you're interested in following that up. It's a really useful document just to give you all the information about the default implicit roles of different HTML elements. Oh, so I've lost that. There we go. It's not moving properly. Has that moved? Oh, I do. Okay, excellent. Love technology. Okay, so how does this work in the browser? Well, you'll know perfectly well that when you load some HTML into the browser, it creates the document object model, the DOM tree. It's a hierarchical representation of the information on the page. What you may not know is that you also get an accessibility tree. The browser takes a subset of the information and it makes all the accessibility bits of it available to accessible assistive technologies. These two things are related. The accessibility tree is a subset of the DOM, but they're quite distinct. They behave differently, and you interact with them in very different ways. You can't, unfortunately, access the accessibility tree using JavaScript as you can with the DOM. The reason is actually just sanity, quite simply. Because of all the different platform APIs, they all do pretty much the same thing, but like browsers, they all do it a little bit differently. So trying to create JavaScript access or a framework that would let us access these APIs would be like the worst kind of cross-browser compatibility you could possibly imagine, and then some really horrendous times just for good measure. So for the moment, you can't use JavaScript to access this information, or more importantly, when you're creating custom controls and widgets, to manipulate it or add in that information for assistive technologies. What you can do is use ARIA, Accessible Rich Internet Applications, specification that version 1 came out last year from the W3C, although we've been using it a lot longer than that. We're working on version 1.1, which is some bug fixes and a few new attributes. And it's a set of attributes that you can add at the moment to HTML, although, as Charles mentioned yesterday, we're looking at ways that you'll be able to add them to SVG2. And these attributes let you change the information in the accessibility tree. Not the information in the DOM, but just the accessibility layer of the browser. So ARIA has a whole bunch of roles. There are more than 30 of them that you can apply. Roles for sliders, tabs, tab lists, dialogues, checkboxes, toolbars, menu bars, menu items, and a whole bunch more besides. Pretty much every kind of application interface control that you might want to create on the web, there is a role or collection of roles that you can use. So a quick example. Remember I said a div is a pretty semantically neutral element. It has no meaning from an accessibility point of view. Imagine if you just wanted a quick push notification somewhere on the screen to let the user know they'd done something, or to give them a time-sensitive message. You can just do that in a div and it's fine. Visually it'll pop up. Sighted people will be aware of it. But there's nothing to tell an assistive technology like a screen reader that this is an important piece of information. So we can override the semantics of the div using the role attribute and a role of alert. And all this role does says to the browser and the accessibility tree, treat this information here inside this div as a little bit more important. What a screen reader will do is, as soon as this content appears on screen, it'll stop what it's doing and it'll announce the content of the div. So you get that notification without really interrupting what you're currently doing, and it serves pretty much the same effect as the visual pop-up does for everyone else. You can add a note in the same way if you've just got a div or even a paragraph containing a little bit of ancillary information to the main content of a page, something that you might in a printed document preface with NB or note. You can add a role of note to the div, and this just sets aside this particular piece of content as being slightly different or outside from the main content. And again, you'd probably style it visually, and this is just the equivalent. It's giving screen readers the information that's available visually in a programmatic format. You've got a whole bunch of states, 9 of them in the ARIA spec at the moment, and these can be used when you're creating controls to indicate whether things are pressed, whether they're invalid, a whole bunch of other different bits and pieces. The ARIA pressed attribute just simply lets you indicate when a button has been pressed. So if you've got a mute button, say, in a media player, someone clicks on it or hits it with a key, the visual styling indicates that it's been depressed, although maybe not so much in these days of flat design. But if you set the ARIA pressed attribute to true, it'll tell assistive technologies like screen readers that this button has been pressed. So it's just really easy to know, pretty much like pressing a manual button, when it's been pressed in and when it's been pressed out. You can use ARIA invalid on form fields. So, for example, if you had an input that was expecting an email address and whatever data was entered wasn't in the correct format, use ARIA invalid equals true. And that'll, again, say to assistive technologies in the accessibility tree, the data in this field is invalid, so it's an error condition. Go back and fix it. And you team that up with other error handling information, like error messages and other bits and pieces. You've got a whole bunch of properties in ARIA as well, and these add in all sorts of characteristics like accessible name through ARIA label or ARIA labeled by, accessible descriptions, also other things like ARIA level, where you can indicate the level of a heading. So something with a role of heading would have an ARIA level of 2 to create the equivalent of an H2, for example. ARIA label is one way of giving an element an accessible name when you can't do it through native means. Just takes a string as a value. The example on screen is just a nav element. Remember I said that this was one of the landmark elements in HTML5. So if we add an accessible name to the nav element, as a screen reader user moves to it on the page, cycles through the landmarks, not only will they now be told it's a navigation region of the page, but in this instance, they'll be told it's the website navigation region. And you can obviously choose titles and accessible names applicable to the type of navigation, but it really builds up on that semantic information that's available. You can use ARIA described by to add an accessible description, probably the second most common characteristic or property that elements have on the web. In this instance, we've just used it to tie a little bit of extra information to an input field. It wants the date of birth, so that's fine, but it requires it in a specific format. So the ARIA described by attribute on the input element, given the ID ref of the element containing the actual text, just means when a screen reader user focuses on this particular field, they'll hear the accessible name, date of birth, but then they'll automatically hear the description as well, so they'll automatically be told what that format is. So it's hooking it all together. ARIA has pop-up is another property that you can use, usually on a button. This one, again, set to true, just indicates that there is a pop-up menu present. So when you hover or focus or interact with the button, a little brief pop-up menu appears. This attribute just lets screen reader users know that that's going to happen. So building up some kind of expectation about what's going to happen when they interact with the button in some way. So if we pull this into a kind of an example that sort of brings some of these all together, this is just a really, really simple slider example, created out of a span and a button element in this case. The span just providing a label that we hook in using ARIA labeled by. Labeled by is similar to label. ARIA label takes a string, so you just give it the name that you want. ARIA labeled by just associates it with another piece of text that's already visible on the page, in this case the label in the span element. We're actually going to override the native semantics of the button element using the role of slider. It's generally something you want to do with caution. If you're using a native HTML element that has a good purpose or a definitive purpose, you want to be very careful about overriding its semantics. But in this case, it's acceptable because knowing that this is a slider, or at least the thumbtack on a slider, is more important than being aware that this is a button. So we'll use the role of slider to do that. There are two attributes that we use to set static information, ARIA value min and ARIA value max. These just tell assistive technologies what the min and max values of the slider are going to be, in this case 0 and 100. And then we have a couple of dynamic attributes. We have ARIA value now, and at any given time that's scripted to contain the current position of the thumbtack on the slider. And ARIA value text. And this is just the human readable equivalent of ARIA value now. So where value now is set to 0, value text is set to 0%, because in terms of a volume slider, that's just a bit more human user friendly. Before I leave ARIA and the accessibility APIs, there are just a few constraints to be aware of. I mentioned that ARIA only affects the accessibility tree. It doesn't affect the DOM. So if you give a div or a button another role, that happens in the accessibility layer, but as far as the DOM is concerned, you're still dealing with exactly what you coded in the first place. So it's quite important to keep that line of separation in your mind when you're thinking about accessibility and continuing other kinds of development. ARIA is also very, very focused on assistive technologies. It's actually one of its flaws. There's a great deal more that we could do with ARIA, but haven't yet managed to accomplish with the spec. So for now, it's just an assistive technology thing. The downside, from your point of view as developers, is that unless you happen to use one of those assistive technologies, ARIA is completely invisible. It doesn't show up on screen in any particular way, so it's really hard to know, A, whether it's there, B, whether it's working, and that makes development a little bit of a challenge. There is a tool, actually, that can really help with that. It's just come out in the past couple of weeks by a guy called Brian Garaventa over in California. It's Visual ARIA, and he's just used, it's a bookmarklet tool, but he's just used some CSS to indicate where ARIA is being used, so you can see it visually. But he's gone one step beyond that, and as you interact with different components and widgets, and the attributes and states and roles change within the ARIA, it'll also show you those changing bits and pieces, but it'll also flag up where things are changing where they shouldn't, so where mistakes are happening. So if you're using ARIA, and it's a good thing to use, check out this tool because it does make life an awful lot easier. So moving on to another API I want to talk about, this one a lot newer than ARIA and the accessibility APIs. The vibration API actually just came out earlier this year, and it lets us create haptic feedback on touchscreen devices, so just simple vibration pulses. It's got great implications for, say, the gaming industry. If you're playing a game on your phone and something explodes on screen, just being able to generate haptic feedback so the phone vibrates in your hand would be just, really nice user experience. From an accessibility point of view, though, we can use it to make things a lot easier, particularly for people who are, say, hearing impaired. The notifications with the role of alert that I mentioned before, if we added in a vibration pulse feedback to that, so someone who may not hear the notification go out, may have missed it on the screen for some reason or another, gets a haptic feedback with the vibration to let them know that a notification has arrived. So there are lots of uses where haptic feedback is a really good thing for accessibility. It's an incredibly simple API, actually, but like most new things, it doesn't have particularly robust browser support at the moment. I think you're pretty much okay in Chrome and Firefox on Android devices, only Android devices, because iOS and Apple haven't given developers direct access to the vibration hardware on Apple devices. But on Android, you can pretty much play to your heart's content. So it is worth just checking to find out whether the vibrate method is available on the navigator object, simple true or false, and just hooking your coding off that depending on what response you get, whether there's support or not. There is only one method in this entire API. It has to be about the most simple API out there, and that's just vibrate. So if you want to create a single pulse, you just apply that to the navigator object. You can do this in two different ways at this point. You can either just give it a single integer value that represents the number of milliseconds you want the vibration pulse to last for, or you can give it an array with just a single index in it for the same, the number of milliseconds that the vibration pulse should last. If you want to create a repeating pattern, then you have to switch over to using an array to do it. This is where it gets a little bit interesting. The even-numbered indices in the array represent the duration of the vibration pulses, and the odd numbers represent the duration of the gap between pulses. So it's, again, really, really simple. I did want to do a demo of this, and I sat there and suddenly realised you really can't demo that in a talk, can you? It's just, unless I get everybody out there doing things on their phones, which would be hugely distracting. But there is, I've just tweeted a link to a demo. If you have got an Android device, you can go and check. And this is basically the simple code for it. It's just a button with the vibration just hooked off of that. There's a couple of ones you can play with. One quick note, though, if you have Android and you have notifications set to priority only, you'll need to disable that if you're using Chrome. Firefox happily trumps all over your priority settings, but Chrome does honour them. So if you're using the demo and it isn't working in Chrome, check your notification settings, because it's actually doing what it should. The last API I want to talk about is the Web Speech API. Again, it's a relatively new one. Again, it's come out of W3C, this time from a community group. And it has two interfaces. The first interface is the speech recognition interface. And this basically lets you create applications that can handle speech input. So pretty much like a speech recognition tool, or like Google Talk, Cortana, Siri, and all those bits and pieces. If you want to be able to control a web application using speech, this is the interface that you can use. You also have the speech synthesis interface, and this handles the reverse, it's speech output. If you want to create an application that is self-voicing or has some kind of speech capability, this is the one that you can use, and it's the one I'm just going to focus on for the next few slides. Again, it's a fairly new API, so support is reasonably limited. Your best bet is either the Chrome or Chrome derivative browsers like Yandex, or Safari if you want to play around with the Web Speech API. And again, so just any scripting, it's just worth checking it. Using a slightly different method here, we're going to see if the speech synthesis utterance is defined on the window object. For some reason, with this API, that seems to be a bit more of a robust way of detecting where support doesn't exist, actually. So, yeah, just again, simple true, false, and hook everything from there. I lost that slide again, or something. Has that moved? Or, huh? Again. Okay, so to create a simple speech, all you do is just create a speech synthesis utterance object, and you can either do this as part of the constructor, just feed it the text that you want to be spoken, when your script is activated. You can actually break this down into two separate pieces and just create the new speech object using the constructor and then attach the text that you want spoken using the .text method, but it's just simpler in this particular case to do it all in one go. And then all you do is just through the window object, just say to the speech object, speak. And hand it the information that you need. And that will cause the default text-to-speech engine on the platform, on the browser that's being used, just simply to say whatever it is. In this case, I think it's tequila, isn't it? You can also choose voices. So most platforms, Windows, Linux, OS X, and so on, have a whole bunch of TTS engines available. So you can use the get voices method just to return a collection of different voices. You can iterate through those and choose one and just give it the index value of the array when you've gone through whatever mechanism you needed to choose it. And you can have quite a lot of fun with that to choose different voices. There are usually male, female voices. There'll be voices for the locale and region that you're in, which will probably be the default ones. You'll also probably get American English, since that's fairly ubiquitous on most platforms, and a whole bunch of other languages as well. Some platforms, I think Google Chrome in some situations has some really silly TTS voices as well, that are kind of like Klingon or something ridiculous like that. So again, you can have a stupid amount of fun playing around with different voices. You can also change the characteristics of the way the voice behaves. Again, quite simple things, but you can change the pitch, the volume, and the rate at which the voice speaks. These are slightly oddly put together to my way of thinking. Volume and rate both default to 1, but you can make them more or less. But the pitch defaults to, volume defaults to 1, and that's actually the maximum volume. So you can never choose to make things more quiet than they are, which it seems like a very strange sort of way to go, but that's the way the spec works. And if I can get Sasha to swap over my audio with a bit of luck and pixie dust, we might get an audio demo out of this, but I'm not counting on it. Are we good to go? I need to, where's my laptop gone?
What do you need?
It's all right, just because. So when I did flip the slide, you're going to hear my screen reader, which is what I've been listening to, which might sound a bit strange.
Page down. Page down.
Hopefully. Play? No. Splendid. Gotta love it. Okay, well, there's a link gone out for this demo. This demo actually was a prototype I put together because I wanted to see what would happen if you could simulate screen reader support for the CSS speech module, which has been around in one format or another for about 10 years now, but doesn't have any support in any browsers ever. And that lets you, or would, if it was supported, let you choose how content was presented in an audio fashion as opposed to the usual visual fashion. So yeah, if you find the link that's just gone out from my Twitter account, you can go and play with that, but it uses the web speech API to simulate the screen reader
Page
support.
down. Slide.
And that's me done, so thank you.
Well, thank you, Leonie. We're a little bit early, so we have plenty of time for questions. Do we have questions? Everyone knows this stuff already. No questions at all. Well, that is interesting because I joke about that, but a lot of the stuff that you're talking about is not hard to do.
No.
So what reasons are cited for not doing them?
I think unfamiliarity. For some reason, people think accessibility is scary, probably because it's unfamiliar. You know, when we design for different devices, tablets, smartphones, desktop, whatever, we've all got some experience of using them, but few of us have actually experience of using assistive technologies or other ways of interacting with content. So it feels a bit kind of scary, I think. The really interesting thing is actually if you've figured out JavaScript, CSS, HTML, cross-browser compatibility, PHP, Java, whatever else, Ruby, Python, you've so done the hard work already. Getting accessibility in it from there is just a pretty small step, really. It's just getting there, taking that first step.
Right, and just using HTML as it was intended gives you a lot of decent accessibility out of the box. So do you notice there's a trend now that we're using a lot of JavaScript frameworks that don't rely on the basics of HTML, that really affects the accessibility of websites?
Yeah, so if you produce, say, an Angular application out of the box, don't do anything to it, it's fundamentally inaccessible to almost anyone who doesn't use a mouse. You can't keyboard focus on anything because all the interactive elements are spans. And if you can't interact with them, that's pretty much game over from an accessibility point of view. And I don't want to single out Angular. They've all got similar problems.
They're all terrible, all of them.
to some degree or another, yeah. There are a lot of good people doing some really good work out there on it. I mean, jQuery actually is a set of frameworks is really good. And actually, I know they're just about to really kind of pick up on accessibility over the coming months. But jQuery UI has got some really good embedded accessibility in it as well. But yeah, things like kind of Angular, Ember, there are people working on it, but there's more to do. So if you want to get stuck in and help, please do.
So what would you say is the simplest thing that people could do like immediately to make their sites more accessible? It takes almost no time to do, but it makes a huge difference.
Go away, unplug your mouse, use the tab key, enter key and space key, and see how much of your application you can use, and then start fixing that. So adding in keyboard focus, you can do that using the tab index attribute set to 0, or just stick an element into the natural keyboard order. And then just checking your scripting where you've got click event handlers, as long as the browser isn't going to do something clever. So if you put a click event handler on a button element, the browser will automatically handle the keyboard for you, like I mentioned. But if you're custom scripting, then check you're using keyboard equivalents as well. So key press, key down, whatever.
Okay. Yes.
Uh-oh.
So HTML has all of these really smart things like the date input stuff. And nobody uses it because it's horrid. And nobody's boss will let them use it. So what should they do?
At the moment, the only thing we can really do is just create custom components and use something like the ARIA design patterns that are available to build in some of the semantic accessibility. Try to keep other accessibility in mind, like color contrast and reasonable keyboard interaction and all of those things. There is a school of thought that says you can use web components to recreate some of these things, but actually, at the end of the day, tactically, that's exactly the same as creating a custom component, a custom widget, just in HTML anyway. So.
And does that actually result in something accessible?
Not necessarily, no. But a hell of an improvement over what you've got, and something that looks the way that the design team and if you do it right, yes, you can, and you end up with something that the design team and the budget holders think looks appropriate for the site as well, which is, yeah.
So I did some projects with accessibility improvements, and what I was often struggling was like finding documentations about it and like good tutorials and stuff where I can see how to do it right.
Yes, that is a big gap. Your best bet actually at the moment is different blogs. So check out the Paciello Group TPG blog, where my colleagues like Steve Faulkner, Patrick Lauker, Ian Pouncey, Hans Hillen all write about ARIA and from a really practical implementation point of view. SitePoint has a few bits and pieces. Smashing Magazine actually has some really good content from accessibility point of view, including an article by Charles and I, which has just been published yesterday actually as part of an ebook, which is a practical approach to creating accessible websites. So there's some good stuff in there as well. But yeah, just checking out blogs is sadly the best place to look for information at the moment. So tracking them down maybe through Twitter and finding people like myself or Charles or Laura, who spoke yesterday, and seeing who we follow and finding blogs through that way and see what they're talking about is probably the best method of getting at that information right now.
Okay, thanks.
Yeah, thanks a lot for the talk. I have a question. I saw this one example where you have a label wrapping an input field, right? Mm-hmm. And for me, when I apply visual styles to input field, this is very nice practice because I have something else than a self-closing element to apply styles with before or after, so I can really freely design my input.
Right.
But you didn't use the for and ID attribute. And I always tend to do that even if I'm wrapping them. So I want to ask, is this okay if I don't use for and ID when I wrap the input? Yeah?
Yeah.
Okay, brilliant.
Yeah, it didn't used to be. going back, and actually it was speech recognition tools that were the problem with this. Going back, I think, a couple of versions of Dragon, so back to sort of 9, 10, Dragon Naturally Speaking is a really popular speech recognition tool. Even when the label element was wrapped around the input, it wouldn't create the association without the foreign ID, but that's not really the case anymore. So yeah, no, you don't need to. If you want to do it for belt and braces, it's not ever going to do any harm, but yeah, it's not needed now.
Thanks for a great talk, Honey.
Thanks.
Question, do we need to keep in mind something in terms of Flexbox SVG for accessibility? I mean, for example, in Flexbox, when we reorder elements, content blocks, do we need to be aware of something in terms of specifically for accessibility?
From an assistive technology point of view, actually no, because I think Firefox in the last version or so has just fixed the problem. So all the other browsers, apart from Firefox, were actually reordering the content in the accessibility tree. So when you rearranged it with Flexbox, from my point of view as a screen reader user, that rearrangement was holding true. Firefox wasn't doing that, but I believe it now is, as of either the current version or the one before. Where my knowledge runs out, and actually you guys might be able to help me, is I presume it does actually rearrange the content visually. So if you were a sighted keyboard user tabbing through content, your tab order would actually match. It really does rearrange things completely, does it? So does that make sense? So if you had, say, 1, 2, 3 in your DOM, and then you rearranged it using Flexbox, a sighted keyboard user, would they get 1, 2, 3, or would they get the tab order of the rearranged content? That's the bit I must.
With tabbing?
Yeah, if you tab through it.
I don't know. Anyone know that?
No.
We should whip up a demo.
First one to a demo by lunchtime.
First one to go into JSPen and whip up a demo gets Fiddly's book. How's that? Is that good? You happy now? All right. Give a hand to Leonie. Did you have a question? All right, we'll take another question. We have time. You'll get like 3 rounds of applause.
I can live with that.
I see a certain redundancy between semantic HTML elements, ARIA roles, and metadata like schema org. Should these all fall together in the future, or is this redundancy a good thing? And the second question, does Google interpret accessibility information?
Do you mean accessibility information from schema or from...
No, ARIA roles, for example. Is this useful information for SEO optimization?
Oh, no, not from a search point of view, as far as I'm aware. But to your first question, there is certainly overlap between what you can accomplish with schema, but where ARIA is more about the semantic information, schema is more about what that information is, and actually Charles is a far better person to answer that question since he's up to his neck in schema as well as other things. So there is overlap, but no, I don't think they cancel each other out at all. In fact, I think there are ways we can probably make it all work together even better. Charles, do you want to?
All right, I'm just running around.
It's cheaper than going to the gym. So stuff like schema really sits on a different level from how the HTML documents work and how you make an individual document accessible, at least the way we do it at the moment. And so there's not a lot of redundancy. The redundancy between HTML semantics and ARIA semantics is there because people keep on doing weird custom things. So yeah, we will keep on needing that. If we make native HTML, so the two of us are involved in trying to make an extension for HTML, which will make sort of tab panel, accordion, carousel type things, straight out HTML elements. If that happens, then at some point after that, you'll be able to throw away all of the ARIA that is used to do that today. But it is an iterative process. People will be using new ARIA to do newer and crazier things instead.
Oh, good.
Thanks. You mentioned that you mainly use the enter, the tab, and the space key to navigate on web pages, right?
To interact with elements like links and buttons, yes. Right. Screen readers actually have a whole bunch of other ways of actually navigating through content. Okay.
So I was just wondering, let's say I'm building a custom drop-down. Is there any way to tell a screen reader that you can use the arrow keys up and down to navigate it?
Yeah, you need to do that in your scripting. So if you look for the look for the ARIA design pattern, you'll find out all the roles and the other bits and pieces that you need. You need to make your JavaScript handle all the keyboard events so that actually interaction works. In terms of telling someone who's using the screen reader that they actually need to do these things, no, you don't, because that should all be available information from the semantics. So as soon as you know it's a list box or a drop-down, because of the roles that you've used, your natural knowledge of how the web works pretty much kicks in, and you just try the things that you would expect to be able to do with a native drop-down.
Right. Thank you.
Like the biggest sigh I've ever heard. So,
So, access key, right? I mean, not for arrow navigation and stuff, but using access key is good. Using JavaScript to hijack user interfaces, it's like, if you can possibly avoid it, don't do that. The user knows what their keys do, and if you start fucking around with it, you are destroying their expectation of how their system works. This is like taking away people's steering wheel just because you thought it would be better if it was square. Right? It's not helpful if you can possibly avoid it. And sometimes you can't, because the web is not that well built. But you should be really, really, really reluctant to step in and rewrite people's interfaces, because you don't know what they were expecting to be able to do beforehand. And that's, this is a problem we are trying to fix, because right now the situation is broken. But, taking access key, which is not very good, and instead using some JavaScript library to hijack people's keyboards, which is way, way, way worse, is not actually the answer.
I would say there's an important distinction, so Charles is right. If you're creating custom controls, like drop-downs or sliders or whatever, you do need to handle the scripting for keyboard support. What I think Charles is more referring to is things like the shortcut frameworks that you get on like Twitter and Facebook, where you've got shortcut keys. Those cause all kinds of havoc for keyboard users, somewhat bizarrely, because they're the people they're intended to help. So to find out what the expected keyboard support for an actual widget or a control is, the best place at the moment is to Google for those ARIA design patterns, Authoring Practices Guide, and they'll have information for sort of common design patterns and the keyboard interaction that you need to provide with scripting, and some examples as well.
so what we're going to do for next year is like put up an MMA, like a cage, so we can have accessibility cage fights.
Woo!
Sound good? Sound good? All right.
Volunteering Charles.
Yeah, he'd be kind of scary.
Yeah.
Don't ever do that. Be very, very reluctant to do that.
The tab order changes when you change.
Did you do the demo? Did you actually
Awesome.
get?
Woo!
Did anyone else do the demo too? Because then, no? All right.
So in that case, to answer the question, no, it looks like Flexbox actually from an accessibility point of view is going to be pretty good.
All right, I thought there was another question. Yeah, here.
Thanks for the great talk. And I've got a question: if there is any possibility for the browser to let the browser know that you use an accessibility device, so I can stop my JavaScript from, fucking with your keys.
No, on desktop there isn't any way to do that. Mobile devices, it's somewhat different. You can tell whether someone's got an assistive technology enabled, or at least in iOS you can. One of the advantages, I suppose, of a closed system. But no, in general, open web, you can't do that right now. And there's actually a school of thought that says that wouldn't really be a very good thing to do anyway, because to do that, you'd have to identify something that's actually quite personal to the user. So just because you use a screen reader, it sort of identifies the fact that that person has a disability, and people may not be comfortable with that kind of sharing of information. there's also the problem that, yes, even if we could get to the point where technically you could tell that someone was using a screen reader, you can't tell why they're using it. So I use it because I can't see anything, but I know people who use it because they're dyslexic and they find reading difficult but listening easier. People who are on the autistic spectrum because they find the clutter, visual clutter of pages too distracting to let them function properly. But just zeroing in on the text and having it as a single audio stream makes stuff more usable. And it's just impossible to know why the assistive technology is being used. But in terms of how and what you'd want to do, keyboard shortcuts may be the exception. It would be really difficult to make a judgment call on what kind of content to serve up or what kind of interaction to support.
Okay, thanks.
Time for one more question. Okay.
Does where's the coffee count? I said, does where's the coffee count?
Question about ARIA hidden. Assuming that there is a good reason to hide something from the existing assistive technology, is this a good thing? Is it reliable? Is it justifiable to use ARIA hidden?
Yes. Yes, it's reliable. I think it works with most recent browsers and screen readers. There is a slight bug at the moment in iOS where if you set ARIA hidden equals false, which is basically show this thing, which is a bit of a strange thing to do in the first place, it does some fairly strange things. So for those of you who are not familiar, ARIA hidden will actually take the element and its content out of the accessibility tree completely. So as far as an assistive technology is concerned, if you have ARIA hidden set to true, that entire chunk of content just vanishes off the face of the earth. There are times, yes, when you might want to make something visually available and not available to screen readers. You really, really need to think about it quite carefully, though. One time I use it, actually, is doing something like creating a disclosure widget on the content to be disclosed on the div that contains that content. You can set ARIA hidden is true, so hide it while the disclosure widget is shut down and collapsed. And then, actually, with your CSS, use the ARIA hidden attribute as an attribute selector on your CSS and then hook in the display property settings in the CSS to the state of the attribute. In your scripting, just update the ARIA attribute, so pull it back into the accessibility tree and that sets off the cascade that then shows it visibly through the CSS as well. So that's one quite neat way that you can use it just to show and hide content when it's more appropriate.
Okay. Thank you all for so many good questions. And thank you again, Leonie, for your great presentation. So please give her another round.
Thank you.